Hello Hodghill. So today is the first lesson on probability. So today you'll be able to find probabilities from a sample space diagram. So the keywords you'll be seeing today are likely, unlikely and probability. So the real life link would be sport analysis. For example, a really historic event happened in America with regards to baseball, where they used sport analysis and probabilities to calculate the likelihood of winning a season with certain players, and it turns out it worked out. Okay, so first of all we need to identify and understand what a sample space diagram is. So what do we use sample space diagrams for? We use them to help determine and calculate probabilities and outcomes of two events. For example, flipping two coins. So first things first, I'd like you to try and consider the situation where we roll two dice and add the scores together, because that's something you'll be dealing with today and potentially on the word wall as well. And that can be represented using a sample space diagram, which I'll be showing you a little bit more in the next slides. Okay, let's go through an example. On the left hand side, this is our sample space diagram. That's this diagram here. And all the bits in the middle, these are our total outcomes. This is how many outcomes we can have. So if we count how many of these numbers we have, that is our total outcomes. So our total outcomes are 36. So we have 36 possible outcomes. Yeah. Okay, so now let's calculate some probabilities now. Yeah. So what is the probability of getting a sum of 7? So let's interpret this sample space diagram. What these numbers represent is if we get a 1 over here and we get a 2 on the second dice, if we add them together we get 3. If we get 3 on the first dice and we get a 4 on the next one, we have a sum of 7. So we need to add up how many of these 7s we have. So if we have a look here, these are all the 7s that we can have, and we have 6 of those. So the probability of getting a 7 equals to desired outcomes, which is 6, we can get 6 of them, divided by the total outcomes, which is 36, and that is equivalent to, if we simplify, 1 over 6. That is because the highest common factor of 6 and 36 is 6. We can divide top and bottom by 6. Okay, next. What is the probability of getting a sum that is odd? So the probability of getting an odd number. Okay, if we have a look here now, we count how many odd numbers we have. If you count all of these odd numbers, we have 18 of them. 18 out of 36. And again, if we simplify, divide top and bottom by 18, we have a half. Yep. And finally, what is the probability of getting a prime or an even number? So if you have a look here, and we write down, let's go with blue, probability of prime or even equals 2, and if we count up how many we have there, we have 32. 32 out of 36. Okay, can we simplify this? Yes, we can. We can find the highest common factor of the two and simplify it. So we get 8 over 9. The highest common factor between 32 and 36 is 4. So we divide top and bottom by 4 and we get 8 over 9. Okay, what I would like you to do now is to pause the video and have a go at finding these probabilities at the bottom. These ones here. That is getting a 3 on the die and a king. So firstly, let me just quickly explain how you're going to calculate that. This region here is your sample space diagram. So if we get a jack and a 1, that is our outcome. We get a 1 and a jack. If we get a queen and a 2, our outcome is a queen and a 2. So have a go at calculating these probabilities on the board. Once you're finished, resume the video and I'll go through it myself. Okay, welcome back. So the probability, I'm just going to put a little, I'm going to denote it here. Probability of getting a 3 and a die. Probability of getting a 3 on the die and a king. So let's look for the ones where it has a 3 and a king. That will only be this one here. So probability to get 1 out of, let's calculate how many total outcomes we have. If we count up how many outcomes we have on the sample space in here, we have 30. So it's going to be 1 over 30. I'm just going to write at the top, total outcomes equals to 30. Okay, next, the probability of getting a queen. So the probability of getting a queen. So we need to have a look here and count how many of these we can get a queen. So we have all of these will have queens. So how many of those do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So it equals to 12 over 30, which is simplified to 4 over 10, which is then simplified to 2/5. Yeah, 2/5. Okay, now the probability of getting a 5 or a queen. Okay, remember it says a 5 or a queen, so we need to highlight any of the ones which have a 5 or a queen. So the ones which have a 5 will be all of these here, and the ones which have queens will be all of these ones here. So how many do we have in total? We have 13, 14. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So the probability would be equal to 15 over 30, which is equals to a half. Okay, and finally, probability of getting at least a 4. Probably of getting at least a 4 on the die and the jack. Let me just rub this out. Okay. Getting at least a 4 on the die and a jack. So, if you're getting at least a 4, you can get a 4, a 5, and a 6. You can get any one of them 3, but you also have to have a jack. It must be a jack. So it's going to be these ones here. At least a 4, so 4, 5 and 6, and you must have a jack. So in total we have 6 out of 30, which is equals to 1/5. 1/5. Okay, so we come on to the main activity. If you are set 5, I would like you to have a go at red and amber, and if you are set 4, I would like you to have a go at red, amber and green. What I would like you to do is take a photo of your solutions and upload them onto ClassCharts. Also, you should see on the bottom right hand side of the screen there's a link. I'm going to attach that into ClassCharts, and you must have a go at the word wall that you find the link to on ClassCharts. Any questions or queries, please message a member of staff on ClassCharts, and good luck.